Good day, grade 10 chemistry students. Today what we're learning about is properties of acids and bases. Now you may have heard of some of these things before. They are dangerous and we're going to deal with some of them in class, but you may not know it, but acids and bases are everywhere and you need them to function in a normal society. So let's talk about acids. Where are acids? Well, one indication and properties of acids when we talk about acids and generally when we're talking about their properties, you can find that they are acids just by detecting these things. For example, anything that tastes sour is generally a little bit acidic. If it conducts electricity, and I'll show you what this means in class as well, electricity can go through the liquid when the acid is there. It might be an acid. If it changes litmus paper red, it's definitely an acid. I'll show you litmus paper. If it's corrosive, if it eats away at tissue, or it breaks things down, it is definitely most likely an acid. Some examples that are in everyday around us: lemon juice, vinegar, hydrochloric acid, which is found in various products, and aspirin is actually an acid. Okay, so acids release H+ when they're in solution. So if you want to find an acid will be something like hydrochloric acid. It has hydrogen in the front. Okay? And when you put it in water, that aqueous means in water, H2SO4, H3PO4. What do they share in common? They all have ions, polyatomic ions at the end, or an ion at the anion in this case for chloride, and they have hydrogen in the front. And when you put them in water, you're releasing these H+ into solution. And those H+, if we take a look at hydrogen on the periodic table, it has two numbers, 1 and 1. This means it's got one proton. How many neutrons does it have if this is the atomic mass? If it has to equal to 1, then you have one proton. This means you have 0 neutrons and just one proton. So in a hydrogen atom, it has one proton and one electron. It likes that electron. To make this an H+, you have to remove that electron. So acids create a whole bunch of H+, and what they're looking for is they're looking for electrons. Anything with any free electrons it will eat away and destroy. So the examples again of acids are H2SO4, H2CO3, HCl, and H3PO4. All have H in the front and all release H+ into solution. Bases, on the other hand, they taste bitter. They are slippery to the touch. They feel like soap. They're corrosive as well. They can break things apart. And they change litmus paper blue. They're equally as dangerous. They also conduct electricity. Some examples are baking soda, drain cleaner, soap, ammonia, and antacids. But generally what they release in water is they release a polyatomic ion called hydroxide, which dissolves in water. And hydroxide is actually looking for H+. Okay? So anything with any H+, it will react. So acids and bases react actually in a way that's kind of dangerous because acids release a lot of H+. So the pH scale shows the strength of an acid or a base, and the range of a pH scale is 0 to 14. So a strong acid has a pH of 2. A strong base has a pH of 12. A neutral acid has a pH of 7. When we look at the scale, it goes from 0 to 14. In the middle is 7 right there. That's neutral. And this is very acidic. Okay? And on the other end, you have something that's very, very basic. So you can say that you have lots of H+ here. Okay? And over here on the scale, you have lots of OH negative. So if your hot tub says, you have a pH of, for example, 5. If your hot tub ever said that, that would be bad for your hot tub if you have a hot tub when you're older. What that means is you have too much H+ and you need more OH negative. You need to go in this direction, so you have to remove the H+ and you have to add more OH negative to make it neutral. So just a few things to keep in mind. Your stomach acid has a pH of somewhere between 2 and 3. Okay? Battery acid is somewhere in that zone as well. Acid rain is somewhere in the zone of 6. I believe milk is in the range of 8. Your blood is right around 7. Okay? If your blood ever got outside of that range, you'd almost die immediately. Okay, so again, stomach acid, pH of 2, battery acid, pH of 1. I was actually wrong there. I said 3. Apple, pH of 3. Tomatoes, pH of 4. Water is 7. Bleach is 12. Drain cleaner, and so on. Well, how can we, if we spill some acid or base, what can we do if this stuff is so dangerous? Well, the answer is we can neutralize it. Neutralize means it bringing a pH closer to 7. We know that if we have an acid plus base, we're actually going to make water plus salt. A salt is a chemistry, the salt in chemistry is an ionic compound. So an example of this is if we have HCl, we know that that acid is going to release H+. And we add it to NaOH, which is a base, we know it's going to release OH negative. So this is our acid, this is our base. When we put these things together, what you're going to end up getting is a form of double displacement. You're going to form Na plus Cl negative. This is your salts. And the other thing that you're going to form is H plus and OH negative. And this makes the pH close to 7. I hope you can figure out why. This compound here is actually the same as writing water. So when you add an acid to base, you're actually neutralizing it to make water. And if you add it perfectly together, which is difficult to do, it's perfectly safe. Okay? So in summary, acids have certain properties, bases have certain properties. When you add them together, you neutralize and you create a pH of 7. A good way of keeping track of if something is an acid or a base is using the pH scale. And we're going to use that in class. That's it for today's lesson. Thanks so much for listening.